I hope you enjoyed learning about tagas. I sure know I did. So until next time, stay toasty and out of this cold weather. Goodness gracious. Whew. Man, that was a lot of work. Talking about tagas gets you quite cold. What are you thinking about doing next? Ah, I see. You want to be warm, don't you? Sounds good with me. I'd like a cruise about now, honestly.
2 hours later.
This is quite nice. This is a great idea.
The next stop is Mangrove Swamps.
Ah, sweet. I always thought those funky looking trees were pretty cool. Mangrove Swamps, the place that looks very similar to the planet Yoda's from. Okay, tell me, you don't see the connection. I know you do. Anyways, this biome is jam-packed with these spider-legs looking trees and a ton of water. These trees can give the image of being on stilts, creating an impenetrable maze of woody vegetation. Mangroves are located only in tropical or subtropical latitudes near the equator due to not withstanding cold temperatures. They are coastal wetlands. That's also why, as you can see with this map, the locations of the swamps are only in between these two lines. They don't go above, they don't go below. They stay in tropical and subtropical latitudes. One of the most common places that mangrove swamps can be found are in estuaries, where freshwater meets saltwater. In the USA, they can be found from the southern tip of Florida along the Gulf Coast to Texas. Fun fact, Florida's southwest coast holds one of the largest mangrove swamps in the world. As you might be able to tell by the many pictures of the mangrove swamps, that there's one plant in particular that really sticks out. This plant is the mangrove tree. These things dominate the wetlands ecosystem due to their ability to survive in both salt and freshwater. These trees are given the term halophytic, or salt-loving plants. In the USA, only 3 mangroves grow: red, black, and white mangrove trees. Red mangroves are easily recognizable by their distinctive arching roots. Black mangroves are often found more inland, having roots called pneumatophores, which help to supply air to the plant while in submerged soils. And then finally, white mangroves grow even further inland, with no distinctive root structures. Some other plants that you may come across while exploring the mangrove swamps will be seaside oxeye, coin vine, rubber vine, saltwort, shoregrass, perennial glasswort, and giant leather fern, as well as buttonwood. Going back to black mangrove, there are some very specific things about it that make it super fascinating. If you take a closer look at their leaves, you may find tiny crystals of salt on the surface. This is one of the adaptations that the black mangrove has to survive in saltwater environments. They can intake salt water, use the water for living, and release the unwanted salt onto their leaves. Another adaptation that the black mangrove has to survive is by its root structure. By having its roots stick out of the sediment instead of growing into it, this allows the roots to breathe air directly rather than taking it in throughout leaves or through the ground. This is why these roots are called pneumatophores, which straight up means air-breathing roots. Some key features to look at with the mangrove swamps are its temperature, salinity, and tidal fluctuation. Its annual average water temperature is above 22 Celsius or 72 degrees Fahrenheit. One thing that makes the mangrove swamps super unique is its salinity level as well. They average 75 ppt, which is parts per thousand. That's almost 2 times the salinity level of the ocean waters. That's crazy. Due to the changing tide levels mixed with the salinity levels, this removes most competition for the mangrove trees. The constant fluctuation brings in new nutrients by the incoming tides and removes waste with the outgoing tides. Moving on to the animals you may come across animals such as the American crocodile, the blue crab, the Atlantic salt marsh snake, the diamondback terrapin, the clapper rail, the Burmese python, the brown pelican, the southern bald eagle, mangrove rivulus, and the red rat snake. Taking a closer look at the brown pelican, one pretty fascinating thing that differs them from most animals is how they feed. Due to the mangrove swamps being so flooded with water, the most common way to consume food is through eating fish. And so they like to fly over the water searching for fish. And when they see fish, they dive down into the water, pick them up, and pull them out of the water. So they practically dive bomb anytime they see a fish and they're hungry. One of the greatest threats to the mangrove swamp is the rapidly increasing aquaculture industry. This type of an industry takes out hundreds of thousands of acres of lush wetlands, clearing the way for artificial ponds to raise aquatic animals for feed, such as shrimp. But not all threats are man-made threats, such as hurricanes. These things are very dangerous for mangrove swamps as well. A simple hurricane can wipe out hundreds of acres as well. A common misconception with threats to a biome is that most of them are caused by man, such as industrialization or urbanization, but this is actually very wrong. There's also a lot of very natural threats to such biomes, such as wildfires or hurricanes or simply tornadoes as well. So with mangroves, in this particular instance, one of the greatest threats other than industrialization are hurricanes because they're always on coastal lines. In the end, mangrove swamps are very distinctive due to their funky looking trees, constant change in water levels, and its crazy high salinity levels, being again double the amount of parts per thousand than the ocean. Anyways, exploring the swamp was pretty fun, but I kind of want to get back on the cruise now. I'm quite curious what we're going to see next.
The next stop is the tropical rainforest. Stay tuned for the next video where we will learn more about the tropical rainforest, just as we did with the mangroves. For the meantime, enjoy the cruise while we head towards our next destination. Until next time.